Hi guys, I keep getting some messages that you're still struggling with DD.1 and DD.2. So let's look at some of those problems and let's see if I can figure out a way to help you from my home to yours. So IXL has flagged this problem on your screen as one that people are struggling with, this type of question. So this does come from DD.1. So if you're done with that, then just bear with me for a minute and I'll get to DD.2 in just a minute. So this question says, a gumball machine contains gumballs in several different colors. If you purchase one gumball from the machine, what is the probability it will be pink? This is called theoretical probability. This is in theory what would happen, and we're going to get into more of that tomorrow. But theoretical probability, what is the probability that if I purchase one gumball from the machine, what's the probability it's going to be pink? So let me get this chart written down quickly and then I will switch screens for you. All right, so that chart showed us, I abbreviated, super messy, just bear with me, that in the gumball machine, there are 9 purple gumballs, 13 yellow, and 11 pink. So we've been doing these kinds of problems. You just have to read through it and make sure that you're being careful. What I'm noticing is a lot of you are just looking at it pretty quick and guessing at answers. Some of you are really, truly having trouble. So slow down. If you miss one, read why you missed it and see if that helps you as well. Okay, so how many total gumballs are in that machine? So we've got to do some math. Guys, you probably need to have, while you're doing your math, not probably, you do need to have paper, pencil, and some kind of calculator. Even if it's a simple calculator, even if it's the calculator on your cell phone, you need to have a calculator. You won't use it on everything, but guys, you're doing math from home, just like you're doing math in class, so you need to have your supplies. All right, so how many total gumballs are in that machine? So what do we need to do? Well, we need to add. So I can do mental math on this, but you could use a calculator. 9 plus 11 is 20. Plus 13 is 33. So there are 33 total gumballs. And remember our math, part over whole. And whole is the same thing as total. And part in this one is what part of the total is pink. The part that is pink is 11. 11 out of 33. So that needs to be simplified. It might take the answer of 11 over 33, but you need to think, can this be simplified? Well, I can see easily that 11 times 3 is 33. If you couldn't see that, you need to go through your factors. So 11 is prime. The only two factors are 1 and 11. And so I would ask myself, does 11 go into 33? Well, 11, anytime you multiply it by a number, you're going to get double digits of that number. 11 times 2 is 22. 11 times 3 is 33. 11 times 4 is 44. So hopefully you would pick up on that. If you divide by 11, you are going to get 1/3. 1/3 of them. So let's switch back screens. If you purchase one gumball from the machine, what is the probability it will be pink? Make sure that you're reading this next section in italics. Write your answer as a fraction or a whole number. So if I'd gotten 3 over 3, that's the whole number 1. But the fraction I got was 11/33. And so your answer would be 1/3. It's not going to let me enter that here. But that's the way you do those kinds of problems. Okay, let's go look at DD2, where I've been getting lots of messages for help. And let's do some of those together again. And I'll see if I can find out figure out where you're having some of your trouble based on the ones I've seen you missing. Okay, so probability of simple events and opposite events. So I feel like some of the errors here are probably reading problems that maybe you did not read carefully what it was asking of you. You pick a card at random. What is the probability that you will get a 2? The probability you'll get a 2. So you have the cards 1, 2, 3, and 4. And what's the probability that you're going to get a 2? I'm getting that written down on my paper. Let me switch back over. So probability, here's our cards. 1, 2, 3, 4. So always make a fraction first. How many total cards are there? There are 4. What is the probability that I'm going to get a 2? Well, how many 2s are there? There are only 1. There's only 1. So we need to, sometimes they're going to ask for the fraction. Sometimes they're going to ask for the percent. So how do we make a percent? We are going to say 1 divided by 4, right? Remember, this is 1. This sign means divided by 4. So because if I had a 1 here, where the dot is, and then this means divided by, and where that dot is, I have 4. 1 divided by 4, so you put it in, working top to bottom. 1 divided by 4 is 0.25. We have been working on this on our homework and warm-ups all year long to turn that to a percent. 2 places to the right, that becomes 25%. So let's go back and let's read what it is asking us. What is the probability of getting a 2 as a percent? It is 25%. Let's look at the next one. You flip a coin. What is the probability that you are going to get something that is not heads? Well, on a coin, there's only one other choice. The other choice is, you could say that is, what's the probability of landing on tails? So there's a 50-50 chance with a coin. 50-50 chance. It wants a fraction, so the fraction for that is, let's take a look. There are 2 total choices. There's 2 possible outcomes, heads or tails. And this said, let me refresh my mind, the probability it's not going to land on heads. Probability that it's not heads, which means tails. That's 1. That's 1 out of 2. That's the fraction. That is in simplest form. Remember, 1 and 2 are counting neighbors. If I had to turn that into a percent, you would say 1 divided by 2 on your calculator if you weren't sure what that was. Working top to bottom, 1 divided by 2. You get 0.5. Remember, that's like 50 cents, right? And 50 cents is 50% of $1. It's half of $1. So use those things that you know. So let's go back. What is the probability that it's not heads? Write it as a fraction, 1/2. Okay, I've seen a lot of errors on a dice. A lot of errors on a dice. So you have to think of what you know. You're going to roll this 6-sided die. That tells you there are 6 possible choices. What is the probability that you are not going to land on an even number? What is the probability you're going to land on a number that is not even? So let's think about that. Let me get rid of this paper. You can see it. So on a die, you have a 1, a 2, a 3, a 4, a 5, and a 6. So your total choices are 6 total choices. I've seen lots of people putting the total in the top. Remember, fractions are part over whole. The total number of sides, and we want the part that is not even. So I can approach this from 2 ways. I could say, what is the part that is even? And then do the complement. Or I could just say which ones are not even. The ones that are not even are 1, 3, and 5. Because 2, 4, and 6 are even. So 1, 3, and 5. So how many was that? That was 3. 3, 6. 3, 6 simplifies to 1/2. And 1/2 is 0.5 or 50%. So let's see what order or what format it wanted our answer in. What is the probability that you're going to land on a number that is not even? And we said 3 of those are not even, 3 out of 6, and we simplified that to 1/2. You spin the spinner once. What is the probability of landing on a 6? Write it as a percent. So the numbers, let me recreate my spinner here on my paper to help you think about it. 3, 4, 5, and 6. And what is the probability you're going to land on a 6? The probability of landing on a 6. So here is my spinner. I have a 3, 4, 5, and 6. It wants to know the probability that I'm going to land on a 6. So that's this one right here. So how many total outcomes are there? Well, I could land on a 3, a 4, a 5, or a 6. There are 4 possible outcomes, 4 total outcomes, but only one of them is a 6, 1/4. So 1 out of 4 chance. 1 out of 4 chance of landing on a 6. Let's go ahead and change that. That is 1/4 is in simplest form. 1 is our numerator. It cannot get any smaller, so 1/4. Or divide 1 divided by 4 to get our decimal. And you get 0.25. And 25 cents is 25% of a dollar. Remember, move that 2 places to the right. 25%. So let's go back and let's see what it wanted. Write your answer as a percent. So let's say I didn't read it carefully, and let's say I put the fraction in. Let's just see what we do when we make a mistake. Okay, so let me submit 1/4. It says, sorry, the correct answer is. So what I've seen in the classroom when I'm looking over your shoulders is a lot of you just go, okay, got it. But what we really need to do is we need to go down and we need to read what it's saying. So the answer was 25%. I answered 1/4%. So it says, remember, the probability is the number of favorable outcomes out of the number of possible outcomes. Right? In that video yesterday, how many things will make you happy out of how many total things? So the things that would make you happy in this one, if you were looking for a 6, would have been landing on a 6. So there was one of those. These get a little difficult because you think, well, it's a 6. Let me put a 6 in there. The question is, how many 6s are there? And there is only 1 6 out of 4 different sections. And so then to solve it, 1/4, and then it says write your answer as a decimal, then convert to a percent. Once you get down here, that's when you're going to say got it. Okay, so let's look at this one. What is the probability that you're going to land on a number less than 4? Probability less than 4, and it's a 6-sided die. So let's look and see what that's going to look like. So again, I might have to write out 1, 2, 3, 4, 5, 6. A normal 6-sided die has one of each of those numbers. And it says a number less than 4. So here's my 4. Does it include the 4? No, 4 is equal to 4. It's not less than 4. So we're talking about these 3 right here. These 3 are less than 4. Let's make sure. What's the probability you land on a number less than 4? That is correct. So less than 4, there's 3 of them. 3 out of 6. And we've already done that one once. That's 1/2, or 5/10, or 50 hundredths, and that is 50%. So let's go back and let's look at the form that it wants that one. Less than 4. Write it as a fraction. So that's 1/2. You spin the spinner once. What is the probability that you're going to land on a number that is not an 8? So let me write this one out. 5, 6, 7, and 8. And we want the probability that we're going to land on a number that is not an 8. Not an 8. So let's look at that. So here's my spinner. I have a 5, 6, a 7, and 8. I want to know the probability of landing on a number that is not an 8. Well, which ones are not an 8? Well, 5, 6, and 7. All of those are not an 8. So landing on one of those would make me happy because that's what I want, not an 8. So there are 3 things that make me happy out of 1, 2, 3, 4 total outcomes. 3/4. If you don't know that, then divide on a calculator. 3 divided by 4. And you get 0.75. Move that 2 places to the right. And you get 75%. Folly. Shh, not nice. We're doing math. All right, so the probability not an 8 was 3/4. Submit. You pick a card at random. Well, we've already done one of those. Let me see if I can find a different kind. Okay, this one's a little bit different. Yesterday in the video, we talked about prime numbers. Prime numbers have exactly 2 factors, one in itself. So one of the things that we need to know is as we're looking at this spinner, we have the numbers 1, 2, and 3. So, and we need one that's probability that it's not prime. Probability not prime. So, probability of not prime. So, prime numbers have exactly 2 factors. 1 is the only exception. 1 is neither prime nor composite. It's not prime and it's not composite. So, we would not count that as prime. 2 is the only even number that is prime. It only has 2 factors, 1 times 2. Every other even number is divisible by 2. And 2 is also divisible by 2, but it's still just one of the only 2 factors, 1 times 2. 3 is prime. So 2 is prime, 3 is prime. 4 is not. It's an even number, 1 times 4 and 2 times 2. 5 is prime, 1 times 5. 6 is composite. You have 1 times 6 and 2 times 3. So remember, after 2, every even number is composite. Every odd number is not prime, though, and we're going to see that in just a minute. 7 is prime. 8's even, so it's composite. 9, lots of people want to say it's prime, but 9 is 1 times 9 and 3 times 3. So remember, not every odd number is going to be prime. Every prime number is odd except for 2. But that's kind of like every rectangle or every square is a rectangle, but not every rectangle is a square. So it's one of those rules. So let me list the next few prime numbers. 11, 13, 17, 19, 20, nope, 21's 3 times 7, 22, 23. And I think that's probably enough for this activity. So the probability of not prime. Well, this is prime, so I can't count that. And this is prime, I can't count that. 1 is not prime and it's not composite. So that's 1 out of 3. They're probably not going to have you change that to a decimal because you're going to get 3 repeating. And so that doesn't make a nice decimal or percent, but we would change that to 33.3 repeating percent if it did ask you to do that. I don't think it would. So what is the probability of not landing on prime? That's 1 out of 3. You pick a card at random. Okay, we can do that one. Let me see if there's any others I think we need to talk about. So here's another one that may help us. You roll a 6-sided die. What is the probability that you're going to land on something that is not greater than 1? So you've got to really think about this one. So probability of not greater than 1. So thinking about this one, I want a number that's not greater than 1. So you got to kind of just really think about what that means. So is 1 greater than 1? No. It is not greater than 1. So that is one I could use. It is not greater than 1. Is 2 greater than 1? Yes, I can't use that. Is 3? Yes. Is 4? Yes. Is 5? Yes. And 6 is also greater than 1. So there's only 1 out of 6 that is not greater than 1. So I think it's going to ask for a fraction because I don't think that's going to be a nice decimal. And it's not. It's 1.6 repeating. And just for practice, that would be 16.6 repeating percent. So since those are not nice and neat, they are repeating, not terminating decimals, I don't think they're going to ask for that. Let's look. What is the probability that you get a number not greater than 1? There's only one of those. Okay, so I'm going to let you watch this video and try to get back at it. I encourage you, if you are having trouble, to make sure that you are writing things down on paper and really thinking through it. I was not just modeling this for you. If I was working through this section and I hadn't practiced it every year for years, I would probably have to write my choices down and really think about the answer. So give it some effort, use some paper and write it down, use some math talk and talk to yourself. You're capable of doing this. You are able to do this. You just need to give it an appropriate amount of effort and write things down. And if you're still having trouble, message me and then we'll see what we can do to figure it out.